Right, welcome back to the deep dive. We are back for more.
Back for round two.
That's right, getting deeper into this.
Deeper, deepest.
Deepest dive. So the whole point of this whole deep dive thing is we look at some sources, we've got some interesting stuff, and we help you get to the good stuff.
All the good stuff, yeah, without having to read all the pages and pages of
Right.
whatever it is.
Sift through it.
Oh, yeah.
So this is the second deep dive of a three-part series that we are doing about fundamental programming concepts.
Fundamental. Gotta have them.
Gotta have them. Gotta start somewhere.
Yeah. Can't build a house without a foundation.
That's right. And the first one we already did, that's out there somewhere.
Out in the ether.
But today we're going to focus on three very crucial areas.
Ooh, 3. Sounds like a magic number.
3, it is a magic number. Data structures, expressions, and statements.
All very important.
All very important.
Yeah.
And we are getting all of our wonderful information and wisdom from the Ada Style Guide.
Oh, the Ada Style Guide.
A classic. A classic. A classic.
Yeah.
So what we're going to do is we're going to try to extract the most important guidelines and insights related to these three areas. And we're going to try to figure out, from the Ada Style Guide's perspective, what makes good programming practice.
Excellent. I like it. Let's dive in.
Okay, so let's dive right in. Data structures. Ada really likes to emphasize how if you structure your data well, thoughtfully, you can really write maintainable code.
Yeah.
Because it helps you keep related data all together.
Absolutely, yeah. Keep it all nice and organized. And it's really fascinating how the guide sort of gently pushes us towards these more robust and clearer approaches
Right.
to writing code. If you look at, say, discriminated records as an example, instead of having to, work with like unconstrained array values, you have the array, but you've got to have separate constraints. You've got to keep track of them separately. The guide's like, no. Use discriminated records. It's basically like saying you have a container, right? This container can hold things, but you can use discriminated records to basically tell the container, hey, you can only hold this kind of thing. And so it knows, the container itself knows what's in it.
Yeah.
It knows what it's allowed to hold, and it enforces that. So you don't accidentally put, a square peg in a round hole.
Right, yeah. And that really helps, right, to prevent those kind of subtle errors that can really just creep in, especially if you're working on a really big project with lots of people.
Oh, absolutely.
Lots of moving parts.
Yeah.
So, yeah, it's about making the language work for you.
Yeah.
To help you not make these stupid errors.
For sure.
Now, let's talk about how to group data that is different, right? Heterogeneous?
It's heterogeneous.
Yeah. But it's all related. The guy's a big fan of using records for this.
Yeah, records are great.
And what I think is really cool about this is they say that this can really boost maintainability and reliability.
Oh, for sure.
Especially when you're doing things like aggregate assignments. And this can even be helpful for mapping structures to I/O devices, how the data is organized on I/O devices. So
yeah, it's like you can almost think about it like you're mirroring the real world relationships, right? Of the data in your code. Because like the guide even mentions, like there's this old style, Fortran style,
right,
of using parallel arrays.
Yeah.
Where, you have all these different arrays and they're supposed to represent different parts of the same thing.
Right. And the connection is not obvious.
Not obvious. Yeah, it's like this hidden implicit connection that you have to keep in your head. Whereas if you use records, it's right there in your face. Like this is how these things relate. And it just, it makes it easier to read.
Right.
Easier to understand, easier to maintain.
Yeah, exactly. Exactly. Although they do mention that there are some exceptions to this, like if you're doing some really low-level hardware interfacing, that can be a situation where the data is just scattered inherently. So you can't really use records effectively.
Yeah, that's true. Sometimes the hardware dictates the structure.
Right.
But yeah, in general, records are your friend.
Okay, so we've talked about those kinds of data, but there's this other kind of data, heterogeneous polymorphic data.
Ooh, that's a mouthful.
Which sounds very complicated, but what it really means is, you're trying to create a system that is flexible and adaptable.
Yeah, exactly. Like you want your system to be able to evolve. New requirements come in, you want to be able to handle them.
Right. And the guide says that instead of using variant records and like a ton of case statements, that we should be using access types to class-wide types and tag types with extension.
Yeah, that's a much more elegant solution because think about it. Tag types with extension, it's basically saying, okay, we have this base type.
Right.
This is like our foundation.
Yeah.
But then we can extend it. We can create these variations of it that have more specific features or behaviors. And then by using access types, we can refer to any of these variations
Okay.
in a uniform way. So it's like, you have a car.
Right.
A car is a base type.
Right.
But then you can have different kinds of cars. You can have a sedan, you can have an SUV. They're all cars.
Right.
But they have their own unique characteristics. And so tagged types with extension lets you model that kind of relationship in your code.
So it's like a blueprint
Exactly.
for a car.
Yeah.
But then you can have all these different variations of it.
And the beauty of it is that it's much easier to maintain.
Right.
Because, with variant records and case statements, every time you add a new variation, you have to go and update all these different parts of your code.
Right. Right. So that sounds like a much better way to do it.
It's much cleaner, much more organized. It just makes your life easier as a programmer.
So the guide also talks about nested records,
Oh, yeah, nested records.
which it almost seems kind of like common sense, right?
Yeah.
Like break down a big complex data structure into smaller, more manageable chunks.
Yeah.
But they do make a point of emphasizing that it's a very good way to do things.
Yeah, and especially when you're dealing with really large, intricate data structures,
Right.
it can make a huge difference in terms of, just how understandable your code is.
Right.
Because it's all about, like, reducing that cognitive load. Right? Like if you have this massive record with like 100 fields, it's going to be really hard to keep track of everything.
Right.
But if you break it down into smaller sub-records, it's like building with Legos, right?
Yeah.
You have these smaller pieces that you can put together to create something bigger and more complex.
Yeah.
And the guide also mentions this hybrid approach
Yeah.
of using composition and type extension together.
Right.
So you have even more flexibility in how you model your data. And one thing they emphasize is, clear naming conventions are really important. Because when you're accessing elements deep within these nested structures, you want to make sure that the code is still readable.
Right. Right. Because otherwise you're going to get lost in all the layers of nesting.
Absolutely. It's like, going down a rabbit hole. You want to make sure you can find your way back out.
So next the guide talks about dynamic data. And they start to raise some red flags here.
Ooh, red flags. Danger, Will Robinson.
That's right. That's right. They say that dynamic allocation should really only be used if you absolutely have to use it.
Yeah, it's a powerful tool. But like any powerful tool, it can be dangerous if you're not careful.
Right. And they say, like, maybe if you need to, like, create or destroy objects while the program is running.
Yeah, or if you need to have multiple references to the same piece of data.
Right.
Yeah.
But, yeah, it's a source of a lot of problems if you're not careful.
Oh, for sure. It's like, playing with fire. You
Yeah.
can get burned if you don't know what you're doing. And the guide, spells out all these dangers, like drop pointers,
Yeah.
dangling references.
Yeah.
It's basically like you've lost track of your memory.
Yeah.
Right? You're trying to access something that's no longer there. And it's like, trying to find a book in a library where the shelves are constantly shifting.
Right.
It's a recipe for disaster.
Yeah. And they go into detail. They talk about initializing access variables.
Yeah.
Making sure you explicitly deallocate memory when you're done with it.
Yeah. Clean up after yourself. Don't leave a mess.
That's right. And having, like, ways to handle storage errors.
Yeah, because those storage errors, they can really sneak up on you. And if you're not prepared for them, they can crash your program.
Yeah, and they even talk about using controlled types to help you manage dynamic data.
Yeah, control types are great.
Within private types.
They give you a lot of control over how the memory is allocated and deallocated.
Right. And they warn against using unconstrained record objects if you don't have, like, a reliable way to reclaim the memory that they're using.
Yeah, because otherwise you end up with memory leaks.
Right.
Which is like, a slow drip, drip, drip of memory that's being wasted.
Yeah. And they even give you this very practical advice about declaring access types and constrained composite objects in, like, the outermost declarative parts of your code.
Mm-hmm.
So you don't run into issues with implicit heap storage.
Yeah, it's like, keeping your tools organized so
Right.
you know where everything is when you need it.
So the overall takeaway here is when you're dealing with dynamic memory, you have to be very careful.
Absolutely. It's a powerful tool, but it's a tool that demands respect.
So moving on, let's talk about aliased objects. The guide says that we should probably try not to use them too much.
Yeah, aliased objects can be a bit tricky.
They can be tricky.
Yeah.
But there are certain situations where they can be helpful. They say, like, for statically created ragged arrays.
Yeah, or if you want to like refer to a part of a data structure but hide the internal details.
Right.
So it's like, you have a secret passageway.
Right.
You can access it, but you don't know where it leads.
And they give a really good example about using alias constant strings for messages.
Yeah, because they're constant. You know they're not going to change.
Right, right.
Yeah.
So that's a safe way to use them.
Exactly.
Okay, so next we have access discriminants. And this seems like it's a really good way to create data structures that need to refer to themselves.
Yeah, like self-referential data structures,
Yeah.
where a part of the structure points back to another part of the structure.
Or even refer to like other parts of the same structure.
Right. Yeah, and the guide points out that access discriminants create this like permanent link
Yeah.
between the discriminant and the object it's associated with.
Yeah.
And that's really important for maintaining the integrity of those self-referential structures because, you don't want those links to break.
Right. And then finally, in the data structure section, they talk about using modular types instead of Boolean arrays
Oh, yeah, modular.
if you need to do bitwise operations.
Especially when you know, like, exactly how many bits you're working with.
Right.
And performance is really critical because modular types they're designed for that kind of bit level manipulation.
Yeah. So it's about like picking the right tool for the job.
Exactly.
Okay. So we talked all about data structures.
We did. We covered a lot of ground there.
We covered a lot of ground
A
there.
lot of data structures.
But that was just 1/3
Just the first third.
of what we're going to talk about today.
2 more to go.
So let's move on to our next third, which is expressions.
Expressions, the building blocks of, well, everything.
That's right. So the guide basically says that if you want to write really readable code, you have to write good expressions. And if your expressions are bad, then your code is going to be confusing.
It's like, if you're writing a sentence,
Right.
if you use the wrong words or you put them in the wrong order, it's going to be hard to understand.
Yeah.
Same thing with code. Expressions are like the sentences of your code.
So let's start off by talking about range values.
Range values, yeah.
So they say that you should use the first and last attributes to define your boundaries for your ranges.
Yeah, instead of hard coding the values.
Right. And even better, they say you should use the range attribute or just the subtype name itself.
Yeah, because it makes your code more robust. Like, if you change the definition of a type,
Right.
if you hard coded the range values, you'd have to go back and update them everywhere.
Yeah.
But if you use the attributes, it'll just automatically adjust.
So it's like, again, making the language work for you.
Exactly.
But they do give a word of caution about using new subtypes to implicitly specify huge ranges.
Yeah.
Because, that can have performance implications.
Yeah, you don't want to accidentally create a range that's like 1 million elements long.
Right.
And then try to iterate over it.
Okay, so moving on. For array attributes, they make a similar recommendation.
Yeah, use the attributes. Don't hard code the indices.
Don't hard code the indices. So, first, last, length, range. All these attributes, use them.
Same reasoning as with range values. It just makes your code more adaptable.
And more resilient to changes.
Right, exactly.
Okay. So the guide also spent some time talking about parenthetical expressions.
Parentheses. Love them or hate them, they're necessary.
Yeah. And they actually recommend using parentheses even if it seems like the order of operations is obvious.
Yeah, it's like, being extra clear so there's no room for misunderstanding.
Yeah. Especially if you're using like uncommon operators.
Or if like the correctness of your expression depends on a very specific order of evaluation.
Right. So basically it's like just be extra clear.
Yeah, don't be afraid to use parentheses. They're your friends.
So the guide also talks about positive forms of logic.
Oh, yeah. Thinking positive. It's good for your code, too.
And they really encourage avoiding negation whenever you can.
Yeah, like don't use negative names for things.
Right. And especially for flag variables.
Yeah, like instead of is not ready, just use is ready.
Right. It's much easier to understand.
It's like, in real life, it's easier to say I'm happy than it is to say I'm not unhappy.
Right. But they do say that there might be times where the negative form actually makes more sense.
Yeah, if it more accurately reflects the logic of your code.
Yeah.
But in general, yeah, positive is better.
Okay. So then we have short circuit forms of logical operators.
Short circuit, yeah, those are important.
And they say these are really important when you need to make sure that the conditions in your expressions are evaluated in a specific order.
Especially if, like, one condition failing could cause an error if the next condition was evaluated.
Right.
Like if you're trying to access an element in an array,
Right.
you want to make sure the array is not empty first.
Right. Before you try to access the element, because otherwise you're going to get an error. Okay. And finally, in the expressions section, they talk about accuracy of operations with real operands. So basically, floating point numbers, fixed point numbers.
The joys of real numbers, they can be a bit finicky,
They can be a bit finicky.
especially when it comes to comparisons.
So their advice is to use less than or equal to or greater than or equal to.
Yeah, instead of equals.
Instead of equals. When you're working with real numbers.
Because equals can be, well, it can be misleading.
Right. Because of the way that real numbers are represented in computers, there's always this potential for imprecision.
Yeah, it's those pesky decimal points.
That's right. They can really trip you up.
So, yeah, better to be safe than sorry. Use the inequality operators.
Okay, so we've talked all about expressions. Now let's move on to our final third, which is statements.
Statements, where the action happens.
That's right. So the guide, they talk about how it's really important to use simple and consistent statement patterns.
Yeah, keep it clean, keep it readable.
That's right. Because if you do that, then the structure of your program will be much more clear and easy to understand.
It's like, if you're building a house, you want the walls to be straight,
Right.
the floors to be level. Otherwise, it's going to be a wonky house.
So let's start off by talking about nesting.
Nesting, yeah, the dreaded nesting.
So their advice is to keep the nesting depth, the number of levels of nesting, to a minimum.
Don't go too deep down the rabbit hole.
That's right. And they even give a specific guideline, no more than 5 levels.
5 levels, that's your limit.
5 levels.
Don't go beyond that.
Now, of course, they acknowledge that there are some algorithms that just inherently require a lot of nesting.
Yeah, sometimes you just can't avoid it.
But they say if you do have to use a lot of nesting, then make sure you're using really clear names.
Yeah, so people can understand what's going on.
And they even give a bunch of suggestions for simplifying deeply nested code.
Oh, yeah, those are helpful.
Like maybe using constants or well-named variables to store some of your intermediate results. Or maybe you could take a really complex piece of logic and break it up into subprograms.
Yeah, modularity is key.
Yeah, and maybe you could use case statements or else-if statements instead of a bunch of nested if statements.
Or maybe even reorder your conditions.
Right.
Sometimes that can make a big difference.
And in some cases, they even suggest just rethinking the whole design of the algorithm.
Yeah, sometimes you just need to take a step back and look at the bigger picture.
So next they talk about slices.
Slices. Those are fun.
And they say that you should use slices instead of writing loops if you want to work with like a contiguous portion of an array.
Yeah, it's much simpler and cleaner.
Right, you just specify like the start and end indices.
And the language does all the work for you.
Yeah.
No need to write a loop.
Okay, so now let's talk about case statements.
Case statements, another essential part of programming.
So the guide's advice is to minimize the use of the other's clause.
Yeah, because it can be a bit of a catch-all.
Right. And they also say that you should avoid using ranges of enumeration literals in your case statements, because if the enumeration type changes, you might get some unintended behavior that you don't even notice.
Yeah, it's like a hidden trap.
And they say that in general, you should try to use case statements instead of a bunch of if-else-if statements.
Yeah, case statements are usually clearer and more concise.
And they even suggest that for maintainability, if you're working with a type that's evolving, you might want to consider using type extension in dispatching instead of a bunch of case statements.
Yeah, that's a more object-oriented approach, and it can be more robust in the long run.
Right.
Because it makes it easier to handle new variations without having to modify a lot of existing code.
And they point out that it's a good idea to use constrained subtypes for the ranges in your case statements.
Yeah, because it makes the constraints more explicit.
Right.
And it helps to prevent errors.
Okay. Now let's move on to loops.
Loops. Gotta love loops.
So they recommend using for loops whenever you can.
Yeah, for loops are great. They're bounded.
Yeah.
You know exactly how many times they're going to iterate.
Right. And they say that while loops should be used in situations where you don't know how many times you're going to loop.
Yeah, but you have a simple condition that you can check at the beginning.
Right. And then for more complex looping scenarios, they recommend using plain loop statements with exit statements.
Yeah, like the classic leap and a half.
Right. But they say that you should avoid using exit statements within while or for loops.
Yeah, it can make the control flow a bit confusing.
Right. And in general, you should try to minimize the number of exit points you have in a loop.
Yeah, one exit point is usually enough.
And they suggest using exit when instead of if-then exit.
Yeah, it's just more readable.
And they also give a word of caution about recursion and iteration bounds.
Recursion. It can be a powerful tool, but it can also be a bit dangerous.
That's right. And they say that it's a good idea to consider setting explicit bounds on both loops and recursive functions.
Yeah, like a safety net.
Right.
So you don't accidentally create an infinite loop or runaway recursion,
Right.
which can, crash your program or even worse.
Especially in a safety-critical system.
Oh, yeah. In a safety-critical system, an infinite loop can be catastrophic.
Okay. So the guide also has some strong opinions about go-to statements.
Go-to statements, the bane of every programmer's existence.
That's right. They say that you should pretty much never use them.
Yeah, they're unstructured, they're hard to read, they're just bad news.
And they point out that Ada has other ways to control the flow of your program that are much better.
Yeah, like loop exits and exception handling.
Right.
Those are much more structured and easier to understand.
And they also have some advice about return statements.
Return statements, yeah, they can be a bit tricky too.
So their recommendation is to minimize the number of return statements you have in a subprogram.
Yeah, because too many return statements can make the logic hard to follow.
Right. They say that it's generally better to have all your return statements at the same level in the subprogram.
Yeah, like in the branches of a case statement.
Right. And they even suggest using comments or extra white space to make your return statements stand out.
Yeah, so people don't miss them.
But they do say that if reducing the number of return statements makes your code less clear, then don't do it.
Yeah, clarity is always the most important thing.
Okay, next they talk about blocks.
Blocks, those are useful.
And they say that you should use blocks to localize the scope of your declarations.
Yeah, so you don't have variables floating around all over the place.
Right. And you can also use blocks to perform local renaming.
Yeah, if you have a long variable name, you can give it a shorter alias within a block.
Right.
Just to make the code more readable.
And you can also use blocks to define local exception handlers.
Yeah, so you can handle errors close to where they occur.
Right. And finally, in the statements section, they recommend using aggregates instead of assigning values to record components one at a time.
Aggregates, they're a nice shorthand.
Right. Especially when you're initializing records.
Yeah, it's much more compact and readable.
Right. And they say that aggregates are also good for passing records as parameters.
Yeah, instead of using temporary variables,
Right.
it just makes the code cleaner.
So there you have it. Data structures, expressions, statements.
The holy trinity of programming.
That's right. And the main takeaway from all of this is clarity is key.
Clarity, maintainability, and error prevention.
That's right. If you write clear code, it's easier to maintain.
And it's less likely to have errors.
And it's less likely to have errors.
And, the nice thing is these guidelines, even though they come from the Ada style guide, they're applicable to any programming language.
That's right.
Because the principles are universal.
So no matter what language you're using.
Whether it's Ada or C++A or Python or whatever.
Think about these principles. Think about how you can apply them to your own code.
Make your code better. Make it easier to read, easier to maintain, less likely to have errors.
And as we mentioned at the beginning, this is just part 2 of our 3-part series.
That's right. We're not done yet.
In the next deep dive, we're going to be wrapping up our exploration of the Ada style guide.
We're going to cover the last set of programming concepts.
So make sure you tune in for that.
I'll see you then.
It's going to be the final part of our deep dive series.
The grand finale.
All right, I'll see you next time.
See you later.
Bye.